Here we have today's teaching assistant, which is poor Max, who really wants to leave because she was just having her dinner. Oh, I'm sorry we interrupted you, Max. All right, you can run away now. Poor little Max. All right, so now I'm going to show you how to run the correlation analyses in chi-squares in SPSS. First, we're going to open up our Monitoring the Future dataset. We'll start with the chi-square analyses. So the way you find these is actually under Analyze, Descriptive Statistics, and where it says crosstabs, short for cross-tabulation tables. So again, Analyze, Descriptive Statistics, crosstabs, and you click on that. And you get some options. So what we originally ran in the lecture notes was age with sex. Let me see this variable, how it's coded. Yep, that works. So we'll do it the same. Age is going to go in the rows. Sex is going to go in the columns. And you can enter more than one variable at the same time, and it'll just give you multiple tables, but we won't do that. We're just going to do our research question. And then what we're also going to select is this here, display clustered bar chart. So we have a graphical representation of what our research question looks like, because that can be very helpful in interpreting our findings. So we'll make sure that's checked off. Next, we'll click on this one here that says exact. So this is what we would use, this exact test, also known as Fisher's exact test, if we suspect that we're going to violate our assumption that there's going to be less than 5 expected counts in any given cell in a 2x2 table. However, we know that's not the case for this variable, so we're not going to click it. The reason for that and why it gives you a time limit per test is because this uses probability computations that are very, very complex in order to run all possible computations of what the variable looks like to get at that exact test, and that can overload some of our computers. So only click on this exact test if you find out when running the chi-square that you have violated that assumption. Otherwise, just leave it as the standard. Next, we want to click under statistics because that's where we're going to get our actual chi-square statistic as well as our effect size. So we want to make sure you've selected chi-square and phi and Kramer's V, which is our effect size. Ignore everything else and hit continue. Next, we're going to hit cells. And this is where we're going to ask for those percentages, because otherwise it just gives us the raw counts, which isn't very helpful because we don't know what percentage that is. So it's not very easy to compare. So we'll ask for both the row and column percentages. What I asked for in the version I showed you in the lecture notes is also the expected counts. So how many people we would expect in each cell if there was no relationship. But that's really not important because it's just theoretical, so we will ignore that. So all we want is the observed counts, which is already selected for you, and then you want to select the row and column percentages. Hitting this create APA style table is not useful because it has too much redundant information, and I do not want to see an SPSS table in your final assignment. So don't try that. We're going to hit continue. You can ignore these 3 options. They're not relevant. And we're going to hit paste. Then we'll highlight our syntax and run it. And here it is. So first table tells us how many people are in our sample, how many cases are missing. And the second table gives us their actual cross tabulation table. So we've got the percentage within age and the percentage within sex. So there's two ways of breaking down those percentages. We would only report one of them within our write-up, as you saw before. I wouldn't report both because it's redundant. So you would report the most relevant. The one I picked was this percent within sex for 18 and older. So showing that almost 60% of males are 18 and older versus 50% of females, to show that male students tend to be older. And then when we go down, here's the chi-square test. We can see Pearson chi-square, our value, that it is in fact statistically significant. And when we scroll down here, we've got our effect size. As you can see, phi and Kramer's V have the same value. You report the value itself. The negative sign doesn't matter. Only because this is a 2x2 table. If it was a more complicated table, only Kramer's V would be usable. Phi is unreliable in more complex tables. And then here's our clustered bar chart. So you can see why this is useful. So even though our sample of female students is larger than our sample of male students, we can see that they're equally distributed between the two age groups. Whereas the male students, these blue bars, a lot more of them are 18 and older as opposed to less than 18. So that kind of tells us that there's something keeping male students from graduating on time. So they're staying in high school longer than they should be. And we might need additional support specifically for male students to ensure that they graduate on time. Though, as we discussed in our write-up, the effect size is actually small or weak. All right, let's run a more complicated analysis. So we'll do analyze the descriptive statistics, and I'll hit crosstabs again. I will kick out these two because my second research question looked at a level of happiness and race of close friends. So level of happiness, and race of close friends. Where is that? There it is. You can see here that SPSS thinks race of close friends is a scale variable, but it's not. It is an ordinal variable. All right, and we don't need the exact tests. It's not necessary. Plus, I don't want to slow my computer down. You do want chi-square and find Kramer's V. And again, you want to make sure you've got the row and column percentages selected. And that clustered bar chart, we're going to hit paste, open up our syntax, and run it. So now you can see a much more complicated table, lots and lots of numbers, which can seem overwhelming, but before you try interpreting it, again, make sure that whether you need to interpret it or not. So here we can see that our significance value is at 0.051, which is just over our cutoff of 0.05. So no, this is not a statistically significant relationship. You could say that it's approaching significance, but it's not actually significant. And we can kind of see that here within our bar chart, how the distribution of the various colors is equally spread out between the three categories. So even though most people are in that pretty happy group, the height of the bars are still in the same order across all three groups. So if, for instance, in not happy group, this blue bar was much, much higher than all the others, then there would be a relationship that you could start discussing. But here it's basically the bars mirror each other, even though they are different heights, because there's different numbers of people within that pretty happy group compared to the very happy and the not happy groups. All right, so now that we've covered chi-squares, let us look at correlations. So correlations are under analyze and then correlate right here. So the one that you want to pick is bivariate, this second option here. We click on that. And what we ran in our lecture was the relationship between number of siblings and our GPA. So we'll stick those two in there. So number of siblings, grade point average. You can see that the default selection is Pearson's R. So this is our parametric correlation coefficient. Beside that, we've got Kendall's tau and Spearman's rho. These two are non-parametric correlation coefficients. So if I had selected an ordinal variable, I would select one of these two, probably Spearman's rho, since that one's most frequently used. You don't need to select anything else here or anything under options. None of that is relevant. All you have to do is put in the two variables you want and make sure that the correct correlation coefficient is checked off. So if it's two continuous variables, Pearson's. If you have even one ordinal variable in there, you need to select Spearman's rho. So I'm going to paste that, find my syntax, hello syntax, and I will run it. And ta-da, here it is. So number of siblings, the Pearson correlation coefficient with grade point average, negative 0.11. So yes, there's a weak statistically significant relationship between one's number of siblings and their grade point average. And as I mentioned, it's a negative relationship. So as number of siblings goes up, your grade point average goes down. Let us run our non-parametric correlation now. So we go to analyze, correlate, bivariate again. We kick these out because we don't want them. And now we're doing what? Risk of trying cocaine and how easy. Or no, risk of trying marijuana. Da-da-da. How easy to get marijuana. And the risk of regularly smoking marijuana. So because we know these are ordinal, I'm now going to select Spearman's rho. I'm going to get rid of Pearson's R because that's only for two continuous variables. And I'm going to hit paste. And I'm going to go to my syntax and I will run. So you can see it's exactly the same as the table above. Now it just says non-parametric correlation. And at the beginning, it says Spearman's rho. Otherwise, the way the table is presented is exactly the same as for a parametric correlation and interpreted in the same way. So our correlation coefficient of Spearman's rho is negative 0.242. So moderate relationship between risk of trying marijuana and how easy it is to get marijuana. Okay. The last thing I'm going to show you is how to create a chart in SPSS for correlation relationship. And you can do that from down here where it says scatter/dot. So if we select that, we will ask for this simple scatter, and we hit define. And then you just put in the two variables in the y-axis and the x-axis. So we'll do it with that first example with the GPA. So grade point average will go on our y-axis because that is our dependent variable, and on our x-axis will go our independent variable, which is number of siblings. And that's all you need to put in, just these two things. Hit paste, select the syntax and run it. And then you get this, which, okay, it's a terrible chart because there's so few options in number of siblings and grade point average. So this was not a good example of a scatter graph. Let's do the other one instead. So again, I went to graphs, scatter graph, simple scatter, and this time I'm going to do my other research question, which was the risk of regular marijuana use. That was our, oh, that's cocaine. Okay, there's the marijuana and how easy it is to get it. I'm just gonna hit okay. Oh, again, with the too few options, the chart looks terrible. Okay, but you kind of get the idea. So the scatter graph plots where all of our options are. The unfortunate thing is both of these variables just have too few options, so it looks terrible. There's got to be a better option here. What has a lot more options? Grade first tribe cigarettes. Let's try that with attitudes towards substances. Okay, this looks a little bit better. So now you can kind of see that there's a pattern to the dots. But again, they're kind of clustered in this weird way just because there's a few options. But the important thing I wanted to show you about this graph, the scatter graph, is if you no, not right click. If you double click on it, you get additional options. One of which is to get the regression line on there. And we talked about the regression line, right? And this is this little option here. And if we click on that, it will superimpose a regression line onto our chart. Then we can just hit the little X button to close it. Go back to the output, and here's our regression line. So it's telling us what the line of best fit is for our two variables, and it is showing us that yes, there is, a probable linear relationship between attitudes towards substances and grade first tried cigarettes. It would have drawn a line onto these as well. So again, double click on it, select this little option here, add fit line at total, and stop going to my syntax. You can see that now the line is going downwards because as we saw, our correlation coefficient was negative. So this is a fun chart that you can include in your final assignment, because I do ask you for the final assignment to include either a chart or a table that summarizes the answer to each research question. So this is something that you can do for the answer to your correlation question, and for the answer to your chi-square question, you can submit this here, the clustered bar chart from the SPSS output. I don't mind using the figures from SPSS, just don't use the tables, because the tables are stupid and repetitive and way too redundant. All right, that's it on correlations and regressions. They're easy peasy. So, no, sorry, correlations and chi-squares. If you want to learn about regressions, I'm more than happy to either do that as a tutorial for a group of you or one-on-one. Correlations are the best. They're a lot more fun than just bivariate analyses, but it also takes a little bit more work, and I know that most of you do not have time for that. So just know what they are conceptually. You don't need to know how to run them or interpret the SPSS output.